Use the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. So for this part, we are going to use the change of temperature between time 2 and 5. So, and we're going to take that as the approximation at t equals 3.5. So h prime at 3.5 equals equals h at 5 minus h at 2 all over 5 minus 2, which is 52 minus 60 all over 3, which then equals negative 2.666 or negative 2.667. The key to this problem is to know that to get the answer you need to use the difference between time 2 and 5. Part B. Using correct units, explain the meaning of the integral of from 0 to 10 of h of t dt divided by 10 in the context of this problem. Use a trapezoidal sum with the 4 subintervals indicated by the table to estimate the integral from 0 to 10 of h of t dt divided by 10. So for the first part, 1 over 10 times the integral of 0 to 10 of h of t dt. You can recognize from this part that this is the average value. So this is the average temperature of the tea in degrees Celsius from 0 to 10. So that's that part, the first part of this problem. And then for the second part, doing the trapezoidal sum, looking at the graph or the table that was given, I'm going to be using it between 0 and 2, 2 and 5, 5 and 9, 9, 10, there's your 4. So plugging this in, you're going to get 1 over 10 times this mumbo jumbo, so 2 times 66 plus 60 all over 2. So this is the average between 0 and 2 times the interval. And the interval was 2, 0 to 2. I'll repeat this, plus 3 times 60 plus 52 all over 2 plus 4 times 52 plus 44 over 2, continuing down here, plus 44 plus 43 over 2, which, using your calculator, will give you 52.9, not 4, 5. 52.95. Part C. Evaluate the integral from 0 to 10 of h prime of t dt. Using correct units, explain the meaning of the expression in the context of this problem. So for the first part, evaluating the integral from 0 to 10 h prime of t dt. Notice that on this you have h prime of t, which means this is true. So the integral from 0 to 10 h prime of t dt will equal H at 10 minus H at 0. So we know H of 10 and we know H of 0. So we'll just go ahead and quickly plug those in. So H at 10 is 43 minus H at 0, which is 66. That's a 6. That's a 3. And that will give us a value of negative 23. Okay. So, second part is explain the meaning of this expression in the context of this problem. This number is the change, the total change between time 0 and time 10. So that means that if I take this number and I add it to time 0, I will get time 10. So 66 minus 23 yields 43. So that's true. Part D. At time t equals 0, biscuits with temperature 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t is modeled by a function b, for which it is known that b prime of t equals negative 13.84 times e raised to the negative 0.173 t. Using the given models at time t equals 10, how much cooler are the biscuits than the tea? So, to solve this, we're going to need to figure out the temperature of the biscuits at time t equals 10 and subtract that temperature from the temperature of the tea at time equals 10. So in this, we only have to solve for time equals t 10 of the biscuits. So to do this, I'm going to start with b at 10 is equal to, we're going to take our initial condition of 100 degrees Celsius and add it on to the net change of the temperature of the biscuits, which was given by this function. So b prime t dt. And what this comes out to be is that b at time of 10 is equal to 34.18275. So now then, looking back at our chart or table, at time of 10, h of t was 43 degrees. So 43 minus 34.18275 is a beautiful number of 8.817. That is the difference between the two. Which one was hotter? The tea was hotter. So that means that, looking back, which is cooler, the biscuits were cooler time t equals 10 by 8.817 degrees Celsius.